Welcome to Curve Sketching and Possible Graphs. All right, so in these ones we're given information and we're going to sketch a graph of a function that satisfies all of the given conditions. It's not necessarily the only graph that would satisfy those conditions, but it's a graph that would satisfy these conditions. Some hints. Number one, I usually start with information about the function, and then first derivative, and then second derivative. And then the other hint is don't do these in pen. These should be done in pencil, and don't be afraid to erase it and refine it and refine it, as you'll see. It's hard to get it right off the bat, right? So you draw it and you go, whoops, that was supposed to be concave up, and that really looks concave down. Whoops, right? We didn't change concavity at the inflection point. Right? So all the little things like that. So don't be surprised if you have to do this more than once just to get it right. All right, so let's start off with the only piece of information about the function itself, and that is right here, f of 0 equals 0. So that means that 0, 0 is a point. Right? So let's put a point there. Right? I will try to make the graph go through that point. I mean, it's possible that, there's a hole in the graph and then that's a point discontinuity and the point's filled in there. But in general, I think we should try to connect the graph to that point. So we have that point there. So now let's go to the first derivative. And the first derivative information is the first line there, right? So this and the two that I check marked are information from the first derivative. So notice it says f prime of -1 equals f prime of 2 equals 0. All right, so if the first derivative equals 0, we know that's a critical point. So, and by the way, this one is in your notes. So we have a critical point, critical points, at x equals -1 and x equals 2. All right, and we know that because the first derivative equals 0. At those values. All right, now those could be, they don't have to be, but they could be possible relative extrema. Actually, I've already said could be. I think could be and possible are kind of redundant. So let's just put possible. Possible relative extrema. At least they are the candidates, right? Those are the only candidates. All right, so let's see what else it says. All right, so we have two possible relative extrema. We have the first derivative is greater than 0 if x is greater than 2. All right, so that means that f of x is increasing when x is greater than 2. Oh, x is greater than 2. All right, so, and we know that because f prime of x was greater than 0, right, when if x is greater than 2. I really should have put up here where I put f prime of x equals 0, I really should have put -1 and 1, -1 and 2 in there. So I'm just going to do this. Just note that x is those values there. All right, so let's see what else we got. And the first derivative is less than 0 if x is less than -1 or x is between -1 and 2. So that means that f of x is decreasing when x is less than or equal to, let's see, I don't want to write this. So we'll write the way I have it. when x is less than -1 or between -1 and 2. All right, so notice we have so notice that x equals the -1 part is in both sections, and it was a critical point. Notice that there's no change in what the function is doing. It's still decreasing. So could x equals -1 be a relative extrema? No, right? Because it keeps on decreasing. Let's make ourselves a little sign chart so that we can make sense of this information. All right, so we have less than -1. That's negative, right? Because we were decreasing, right? So, oh, you know what? I forgot to write one thing in. We just want to write how we know this is true. All right, so let's put the proof in there. And our proof is that f prime of x is make sure I'm looking at the right one, is less than 0. There he is. If x is less than -1 or -1, between -1 and 2. All right, so now let's do our sign chart. So we have the two critical points, -1 and 2. Those were the critical points. And the first derivative was 0 at those points. Right? We have less than -1, any number less than -1, and it says that the derivative is less than 0, so it's negative. Right? Between -1 and 2, right? It's still negative, right? Because it says right there, the first derivative, right in that line right there. First derivative is less than 0 if x is less than is in between -1 and 2. So we are still decreasing. So anything between this area here, between -1 and 2, I'll just write it like this. So between, -1 and 2, whatever it is, right, that was still negative. And then greater than 2, positive, right? So we see that we have let's take a look at our sign chart here. There's no change in sign at -1, right? Decreasing on either side. So this is not a relative extrema. Not a relative extrema. No, but here we go from negative to positive. That is a relative extrema because there's a sign change. What kind of relative extrema? This is a relative minimum. So there's a relative minimum there. All right, so now let's justify what we've got here. Let's explain our sign chart because we never want to go with just a sign chart. So f of x has a relative minimum at x equals 2, and I'm going to use a symbol for because f prime of x changes sign from negative to positive at x equals 2. Notice I said, who has the relative minimum? It's f of x. How do I know? F prime of x changes sign. It goes from negative to positive. Right? And then we know that x equals -1 is not a relative extrema. Because f prime of x does not change sign. I don't know why I didn't use a symbol for because on that because, but oh well. Does not change sign at x equals -1. All right, so that's not an extrema. All right, so we've got that part. All right, so now let's take a look at the last part of our graph. So we know that we're going to be, don't draw this, all right? So until I get to the final one, don't bother to draw it because I'm going to end up changing it and moving it around and fixing it. So when I'm done, I'll say, now you can draw it, all right? But let's just take a look at what we're doing here. So we are going to keep on decreasing until we get to 2, and then it's going to increase. All right, so I'm probably going to change where this goes, but we're decreasing because we haven't considered concavity. Decreasing, 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 oops, decreasing, and then at 2, increasing. That's a terrible. There, a little bit more U-y, right? So something along those lines, all right? Now that, we're not totally done with that yet. We're going to improve that because we have not considered the concavity, all right? So let's take a look at concavity. So we're not done. All right, so now that would be the second derivative, all right? So actually, I'm going to put 2 X's, or 2 check marks, because that's the second derivative. All right, so it says that we have f double prime of -1 equals f prime of 1 equals 0. So we have critical points at x equals -1 and x equals 1. So those are possible inflection points. And how do we know? We know that because f double prime of, and this time I'm going to put the x in there, -1 and f double prime, actually let's just put an equals here, equals f double prime of 1 equals 0. Let's make that a nicer equals. Yeah, there we go. All right, and let's look at the rest of this. So f double prime of x is greater than 0 if x is less than 0, x is less than -1 or x is greater than 1. All right, so that means that f of x is concave up when x is less than -1 or x is greater than 1. So we haven't considered that part in our graph, right? And actually, I need to fix it slightly. I actually almost have it. It wasn't a bad guess on just the first derivative because I'm almost good. I just got to fix the concavity just a little bit on the negative side so far. Let's see what else I had to fix though. So concave up on those places, and we know that because f double prime of x is greater than 0 if x is less than -1 or oops, I don't know why I put an equals in there, it's twice. Whoop, is less than -1 or x is greater than 1. Boop. All right, and then f double prime of x is less than 0, so that means concave down if x is between -1 and 1. So f of x is concave down on between -1 and 1. I just put on. -1 and 1. How do we know that? Because f double prime, it's hard to write down to all the bottom here, of x is less than 0 when x is between -1 and 1. There we go. All right, so now we have one last little part to put in here. We need to put in the sign chart. I need a teeny bit more space. Maybe not that much. I don't need that much more space. It's a sign chart and an explanation. I still want to be able to see. Oop. I'm probably going to stop the tape between each one of these, just so that it's not each video is not too long, and I never have to stop it in between while I'm still finishing up a graph. All right, so let's do a little sign chart here. All right, so the critical points were -1 and 1. I don't think I give myself enough space. After all, there's more space on the computer screen than on the actual smartboard, because it's the smartboard's just a little off. Well, I think we have the information already written down, so it's okay if we can't see the top. All right, so the critical points were -1 and 1, right? So we're going to consider x less than -1, between -1 and 1, and greater than -1. By the way, you can write down the writing I'm doing. Just don't do the graph until I tell you, because now I'll fix my graph based on this information. All right, so less than -1, it was concave up. It was positive. It was greater, right, than 0, and it was greater than 0 here, and it was less than 0 here. So notice we do have a change in sign, so that does mean that both x equals -1 and x equals 1 are inflection points for, and we should say who? F of x, and that's because f double prime of x changes sign. So the second derivative, you can write second derivative, or you can just put f double prime of x, changes sign at x equals -1 and x equals 1. All right, so all we got to do now is finish our graph. Right? And if you need to, like I went too fast and you need to stop and write this down, just pause me. All right, so now we are really close on this graph. It's just not a real clear change in concavity on concave up and concave down. If I fix that, if I make sure right here that I am clearly changing concavity, then we're good on our graph. Now, I will warn you right now, I have the most trouble with the concavity part and getting that right. All right, I'll go and I'll draw it and I'll be like, oh, that's not, I don't have an inflection point at -1. I didn't do a good job. So it's not that easy, all right? But you get better as you try it, and you just keep refining it. So if you look and you go, oh, I didn't change concavity. Okay, so now I'm concave up. That's good. But I need to hit concave down. I need to change right at -1. And you can see how not good I might do this. All right, let's see. Let me see. I think if I go backwards. So I need to make it change right here. All right, we're getting better. Getting better. It needs to be a clear change in concavity. Like I don't even care where it ends, what the y value is. I just need to make a clear change in concavity. I think I will take that. I think I will take that. It appears to, so right here, I'm going to put our points on here. So right here, that's an inflection point. That looks pretty good, right? Because this is concave up, not concave up, concave. concave up, that looks pretty good. Right over here, concave down. I'm going to move now inflection point because I can't fit the words concave down. That looks pretty good. Concave down here, that looks pretty good. So long as we have the last inflection point, which was at x equals 1. And, okay, we failed at that one. I don't think that's a clear inflection point there. So we're concave down. Now we just got to get this change in concavity right here at 1. And then, maybe if I come from both sides, get inching closer. I think I'll take it. I think I'll take it. Definitely, so, and these are the inflection points. Inflection point, it does appear to be concave down. It is concave, it doesn't appear to be, it is concave down right here. That looks not like a W. It is definitely concave up here. All right, we accomplished that. Got inflection point here, an inflection point there. That looks pretty good. Now, if we got a relative extreme at 2, almost, right? Just a little, if I could make that right here, have that horizontal tangent line, we got it. And, you know, if you were really close, and of course I can do this, let's get that in there. Oh, so close, but it looks like it's at 2.5, doesn't it? I would say that relative extreme is at 2.5, not at 2. We got to get it at 2. Maybe if I cut this short, maybe if I get rid of this altogether, because this is not my issue here. My issue is getting that. Yes, we did it. We did it. There, very clear. We got to. I'll put it in blue. We got it. There is the relative minimum. This graph is good. So now this is, I'm not going to write this. In the past, I've written this down. But just understand that this is a possible function that meets the requirements. It is not the only function. Actually, maybe I'll write this down on the next page. You don't have to write this down. But just so that you understand that this is not the only function, this is a function, right? I could, oh, I almost forgot. There's 0, 0. And but the graph goes through, I don't think I can move it. Oops, no, go away, go away, go away. Graph goes through 0, 0. Oops. If you draw the point big enough, it's good. Hey, this is a smart board. I can only do so much. All right, there we go. 0, 0 was a point on the graph. We got that. It's a slight inflection point there, but you can see there's definitely a change in concavity there. All right, so this is our graph. Go ahead and draw it. It's good. All right, and you saw how many times it took me, and I knew what I wanted to draw. Sometimes it's hard to go from what you know it should look like to getting it to be just right, especially on a smartboard. So I'm going to end this video with just one little piece of information, all right, so that it's very clear, and you don't have to write it down unless you want to. But this is so that one and all the ones that will follow, these are possible functions that meet all given requirements. It'd be nice if my writing would show up the same time I actually did the writing. They are not the only possible functions. All right? There are lots of things we don't know. We don't know, come on, x-intercepts, or all, I should say, because we had one. We do have the y-intercept. Matter of fact, we only know 1 point. We do know the only y-intercept. There can't be two y-intercepts. Otherwise, you're no longer a function. Only know 1 point on that particular graph. On the previous graph, oops, missing a U there. On the previous graph, and won't know all points on those to follow. So you don't have to write this down. This is just to make sure it's clear that this is only a possible graph. You don't have to sit there and go, is this right? I don't know what points it goes through. Just make sure you go through the given points, right? And make sure you meet the criteria and you explain the criteria. We won't know all points on the upcoming graphs, right? So just want to make sure that is clear. You don't have to write this down. Just make sure you understand that. But this is the only graph that's going to be on this video. I'll pick up with the next graph, and I can probably go just a little faster now that we've done one, all right? Bye for now. Thanks for watching.